This video is going to be about the density parameter, which we represent with the symbol omega naught. The density parameter is the ratio of the actual density of the universe and the critical density. So the density parameter is equal to the actual density of the universe divided by the critical density. So let's look at how different density parameters for the universe would affect the cosmic scale factor R over time. Just for the sake of arbitrary reference, let's say we're relatively near the beginning of the universe, so this is now. So the first situation, let's assume the density parameter of the universe is 1. If the density parameter of the universe is 1, that means the actual density and the critical density of the universe are the same thing. So the universe is at the critical density. In this model, gravity would slow the expansion of objects in the universe, but gravity's pull would never bring them back to their original starting position. This is sometimes called a flat universe. Matter in this universe would expand until eventually it reached a maximum limit, and then it would stop as the kinetic energy ran out. A flat universe would make a nice straight line, just like this. And so the universe would expand over time with the scale factor would expand over time, as shown here. The next one, let's assume that our density parameter is less than 1. So we have a very not dense universe. So meaning the actual density of the universe is less than the critical density. Unlike the flat universe, this universe would expand forever and never come to a rest at a maximum. We call this kind of universe an open universe. It has a similar straight line that increases its scale factor with time, and it's a little steeper than the flat universe. Okay, what if our density parameter was greater than 1, meaning that the density of the universe was greater than the critical density? In this universe, gravitation would be able to pull everything back to its original starting position after bringing everything to a stop. So it would expand at first and then collapse. Sometimes this collapse is called the Big Crunch. This one will have an increasing cosmic scale factor, which will come to a stop, and then it'll decrease and return back to the point where it started. We call this kind of universe a closed universe. So based on observations, do we have an open, closed, or flat universe? Actually, we have something that's neither any of these. We actually have an accelerating universe where the scale factor isn't increasing linearly, it's actually increasing like this. All right, and we'll talk about how dark energy might explain the accelerating universe in the next video. All right, that's the end.